In this video, I'll show you how to build this impact drill train horn with a remote control that works from up to 160 feet away. You can actually build your own for as low as $64 in parts, assuming you already have an old impact driver lying around. Of course, if you need to buy the driver, it will cost a bit more, since that's obviously the biggest part of the expense. Also, I'll show you the full cost summary and explain where to get the best deals. And at the end, we'll test the remote control distance outside. To make things easier and save you some time, I've added timestamps below so you can jump straight to the parts you need. All right, let's get started. I'll be using this DeWalt impact driver. You'll find a link to it in the comments. Next, we'll need a 4-trumpet train horn. Sometimes these come with a valve installed. If that's the case, you'll need to buy a fitting separately and just toss the valve. The one I'm using already comes with the correct fitting. Now, the compressor. I use a 12-volt compressor, even though the DeWalt battery runs at a higher voltage. In my experience, this setup actually gives you a stronger horn sound, and I haven't noticed any negative impact on the compressor's lifespan. Trigger button. I'm not using the original trigger inside the impact tool because it works together with the tool's control board, and I removed that completely. You'll also need a remote control receiver and the remote itself, and a 30-amp automotive relay. These are the core components you need. At the time of filming, they cost $64.36 without the impact driver, or $142.24 if you need to buy the driver. But that's not all. You will also need consumables, electrical crimp connectors, and electrical tape. Personally, I prefer using 3/16 of an inch or 5 millimeters heat shrink tubing. You'll also need electrical wires, vinyl tubing with a 1/4 inch inner diameter, 3/4 inch hex head screw, and a door seal strip. I use that between the housing and the compressor to keep everything secure. Now, you might already have some of this lying around, but if you don't, buying all these supplies separately on Amazon will cost you an additional $76.40. Of course, you'll have a lot of leftovers that might come in handy for future projects. If you don't want to clutter your garage with extra stuff or waste that extra money, here's a better deal. You can order the complete DIY kit on my website. It costs the same as buying just the main parts on Amazon, but it includes the exact amount of supplies you need, so you instantly save at least $76. And if you don't want to mess around with wires and soldering at all, you can also order a pre-wired set to save even more time. You know the drill. All the links are in the description. For this build, you will need the following tools: a Torx T10 bit, a 3/16 inch drill bit, which is about 5 millimeters, a 10 millimeter socket, a soldering iron and solder, wire strippers, micro wire cutters, and side cutters. I also personally like using locking forceps to hold the wire while I'm soldering. It makes things much easier. A digital multimeter is very helpful for testing. And finally, a power drill and a glue gun. All right, let's get started. First up, let's take apart the impact driver. By the way, I watch a ton of DIY videos myself, and here's a little hack I use. If I think I might get distracted or interrupted, I just hit the like button. It basically signals the YouTube algorithm to remind you about this video later by popping it back into your feed. So give it a try. It's a great way not to lose the guide halfway through or just to easily find it later in your library. And at this step, make sure to disconnect the connector plate. We are going to need that. Everything else inside is useless. The next step is preparing the mounting holes to attach the horns to the drill housing. Temporarily screw the housing back together so we can mark the positions. Now, I know exactly where these need to go, but for you, I recommend doing a dry fit. Hold the horns and double check the alignment. You want to make sure the setup isn't sitting too high or too low. Alternatively, you can just aim to place the holes roughly in the middle. Go ahead and drill those holes, then set the housing aside. At this stage, we're going to assemble the electrical part. I'll cover a bit of basic theory here to make sure beginners understand exactly how this works. If you are already an expert in electronics, feel free to skip ahead. This is the trigger switch. Basically, its only job is to open and close the circuit to let the current flow. Here is what matters for us practical-wise. Power goes in through this bottom contact. When you pull the trigger, that power travels out through this contact on the top left. Let me hook up a multimeter to show you exactly how it works. Watch this. The current comes in from the bottom on the red wire, and when I squeeze the trigger, it flows through to the black wire. You can see the continuity right there on the screen. That is exactly how we are going to wire it up. One important detail though, take a look at this little switch here. That's the reverse selector. If you're using this exact same trigger, make sure the switch is in this position, just like mine. That ensures the connection is made between those specific contacts. If you're using a different trigger, you'll just need to test it yourself to figure out which pins are active. This is a 30 amp automotive relay. Its job is simply to open and close the circuit. Here is why we need it. When you hit the remote button, the receiver picks up the signal and tells this relay to close the contacts. That fires up the compressor, creating that massive sound. Now, look at the connections. There are 4 pins here. These 2, running parallel to the longer side, are the control pins. This is where the low power signal from the receiver comes in. And the other 2 are the power pins. These complete the main circuit that actually drives the compressor. And finally, here is the receiver. This picks up the signal from the remote, and it has 5 wires in total. The black and red ones are for the main power input. We'll connect those to power up the system. The white and blue wires are the control lines. These are the ones we'll connect to the relay. And this last wire is the antenna that picks up the signal. That wraps up the theory. Now let's move on to the next step and solder everything together. And for those who need a visual guide, remember you can find the full wiring diagram and a step-by-step text guide with pictures on my website. The link is in the video description. Now let's get the wires ready. You'll need 4 pieces of black wire, about 4 inches long each, and 1 piece of red wire, 9 inches long. First, solder a black wire to the negative contact on the connector plate we saved earlier. Watch closely here. You don't want to mix up the positive and negative terminals. Next, solder the other end of that wire to the bottom contact of the trigger switch. Now, take a second black wire, solder it to that same bottom contact on the trigger, and run the other end to one of the power pins on the relay. At this same spot on the relay, we also need to solder the black wire coming from the receiver. On the other power pin of the relay, solder the third black wire. Now for the 4th black wire. Connect it from the top contact of the trigger switch to one of the control pins on the relay. You also need to attach the white wire from the receiver to this same control pin. And on the remaining control pin, attach the blue wire from the receiver. Now, take the long red wire. Solder one end to the positive terminal on the connector plate. Twist the other end together with the red wire from the receiver and crimp a connector onto them. Attach another crimp connector to that loose black wire coming from the relay. That completes this part of the assembly. Let me show you how this electrical setup actually works. I'll hook up the multimeter to the clamps, plug in the battery, and pull the trigger. See those readings on the display? That confirms the current is flowing from the battery through the system exactly when I pull the trigger. Finally, let's pair the remote control to the board. Find the small black button on the receiver board. Press it once. The LED will light up, signaling that the port is open and it's ready to learn the code from the remote. While that light is on, you have a few seconds to press the button on your remote. The receiver light will flash to confirm it memorized the code. Now, whenever you press the remote, it will trigger the relay to close the contacts and blast the horn. Here's a very important detail. If you press the receiver button twice during pairing, it enters a different mode. In that mode, one press turns the horn on and keeps it on continuously until you press it again to turn it off. You usually don't want that for a train horn. If you accidentally get into that wrong mode, you need to reset the receiver to factory settings. To do that, press the small button on the receiver 8 times in a row. The LED will flash to confirm the memory has been wiped. This part of the build is complete. Let's move on to the next step. Now we need to arrange all the components inside the housing and lock them in place. I usually position the receiver right next to a vent or an existing hole in the case. You want to make sure that pairing button is accessible from the outside. That way, if you ever need to pair a new remote later, you won't have to tear the whole thing apart again. I secure the receiver board using a standard hot glue gun. You should also use the hot glue for the trigger switch. Since this is a universal switch and not custom molded for this specific drill housing, it needs that glue to stay solid. Pay attention to the white antenna wire. Try to route it so it's stretched out as much as possible inside the case. This maximizes your signal range. I'll show you exactly what kind of range we get with this setup at the end of the video. Before installing the compressor, you need to remove these 2 little tabs here. If you don't, they will get in the way and the case won't close properly. And finally, since the compressor is slightly smaller than the drill housing, I use some foam weather stripping tape to fill the gap and keep it snug. Take a close look at the polarity markings on the compressor. Connect the red wire to the positive terminal and the black wire to the negative. Once that is connected, tuck the compressor and all the components neatly into the housing and screw the case back together. Let's give it a quick test. Now let's move on to the final step. Screw the horn base onto the housing. Connect the air tubing, just cut it to the length you need. Finally, screw on the trumpets. And as I promised, let's head outside to do the range test.